Okay, today we're going to look at solving polynomial equations by factoring. You're going to learn to do them by factoring, and actually we're going to learn to do them by graphing as well. So just as a reminder, when you are solving polynomial equations, you have to consider imaginary roots. And we're also going to use the zero product property that basically says if a times b equals 0, then either a or b or both must be 0. And so that implies that if some equation is factored and set equal to 0, you can set the factors equal to 0 and solve. So this is already set equal to 0, so we're just going to solve. I can factor x squared minus 1. It's a difference of squares into x minus 1 and x plus 1. But x squared plus 4 I can't factor. So now I can set all three of those equal to 0, and I get x minus 1 equals 0, x plus 1 equals 0, and x squared plus 4 equals 0. So now I'm going to add 1 to both sides, so x is 1, subtract 1, so x equals negative 1, subtract 4, so I get x equal to negative 4. Now I got to take the square root of both sides, and that's going to give me positive or negative 2i. So remember, whenever we take the square root of a negative number, we get an imaginary number, and we have to consider both those roots. So my solution set for this is going to be, we can write this as plus or minus 1, or positive or negative 1, and positive or negative 2i. Now we could have, from this form, set this equal to 0 and taken the square root of 1. Just remember, you've got both roots. A lot of people forget that second root. Right. Now this is not set equal to 0, so I'm going to bring everything over to one side. So I'm going to subtract 8x from both sides. So I get 2x cubed minus 8x, and then I'm going to add 2x squared. And I'm actually going to put that in descending order, so plus 2x squared plus 8, or minus 8x. So I have subtracted the 8x from both sides and added the 2x. So now I'm going to factor out a greatest common factor. When I do that, I get 2x times x squared plus x minus 4 equal to 0. So now I can't factor x squared plus 4 minus 0 because the only factors of negative 4 are going to be negative 2 and 2, and when I add that I get 0, and negative 1 and 4, and that gives me 3. So I can set these equal to 0. So this case, x will be 0. Here, I can solve any way that I want. You can use completing the square. You can use the quadratic formula. If I use the quadratic formula, remember it's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now I like completing the square, but that's going to give me a fraction, so I'm not going to use that. So when I substitute my a, b, and c in, remember this is 1 and this is 1, so I get negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 4 all over 2 times 1. Okay. Inside my square root symbols, I'm going to get 1 plus 16, which is 17. So negative 1 plus or minus the square root of 17 over 2. And I'm done. That can't be simplified any further. So my solution is -1 plus or minus the square root of 17 over 2 and x equals 0. And I'm just going to leave it that way. Right. In this case, this is factored, but not really. I've got both sides are factored, but when I set them equal to 0, if I do x times x squared plus 8, and I subtract this whole thing, -8 times x plus 1 equal to 0. Notice that it's a subtraction in here, so it's not factored. So what I have to do is I've actually got to distribute this, so I get x squared plus 8x minus 8x, and then -8 equals 0. And if I combine my like terms, I get x squared minus 8 equals 0. Now this is a difference of cubed. So the cube root of the first is x. The cube root of the second is 2, so x minus 2. And remember, we use SOAP, same, opposite, always positive. So I squared this term, and I get x squared. Multiply these, minus 2x, and square the last. Actually, this is opposite, so plus 2x, always positive, 4 equals 0. In a difference of squares, that trinomial can never ever be factored. So if I set these equal to 0, I get x minus 2 equal to 0, x squared plus 2x plus 4 equal to 0. So here x equals 2, and this one, because this is divisible by 2, I'm going to complete the square. So x squared plus 2x equals -4. Half of 1 is 1, and 1 squared is 1. So I got to add 1 to both sides. So remember, I halved the b and then squared it. So this factors to x plus 1 squared equals -3. If I take the square root of both sides, I get x plus 1 equals the square root of -3. Okay, and now if I bring this over, I get x equals -1. This should be plus or minus. And I'm going to take out an I because of the negative, so plus or minus I root 3. So these are two solutions, and this is 1. Notice that my degree is 3. I don't have 3 real solutions, but I have 1 real and 2 imaginary solutions. What you're going to find is, remember that they come in pairs, imaginary. You can also find the roots by graphing. So the x to the 4th minus 3x squared equal to 4, this is the graph of its related equation. So what I mean by that is that my little Penn State pride. So I'm going to subtract 4 from both sides, so I get x to the 4th minus 3x squared minus 4 equals 0. And I just replace the 0 with y and graph that. Okay, so my solution is going to be where it crosses the x-axis. So here and here, so my solutions, my real solutions, are going to be -2 and 2. Okay, so this is the point -2, 0, and the point 2, 0. Now my degree is 4, so that means that I have 2 imaginary roots. The reason I say real roots is because this is a real number system and the graph is a real number plane, so you can't find imaginary roots by graphing. So you're limited when you solve by graphing. All right, so today we looked a little bit at how to solve polynomial equations. We'll look at it a little more in the next lesson. So have a math-tastic day.